All right, good morning, everyone. Welcome to the track 5 of this CIB Smart Built Environment Conference. My name is Dr. Saeed Ajayi. I currently work at Leeds Beckett University here in the United Kingdom. So I'll be sharing this session, which is track 5. And for this session, we have 6 presentations. So I'm sure we already have some of the presenters here. So we'll start playing the presentation, and the first one is going to be the one by Yuan Chen, which is on the review on embodied carbon reduction strategy of iron and steel building projects. So we'll listen to the presentation, and this will be followed up with some questions, 1 or 2 questions before we are going to move to the other presentation subsequently after that. So if you start sharing now, Ali, so that would be helpful.
The topic of this study is a review on embodied carbon reduction strategy of iron and steel building products. The building sector, including the construction of building, puts the most environmental pressure on the earth. Speaking of the primary energy consumption and greenhouse gas emissions or carbon emissions, it ranks number 1 among all the sectors. Among these, the embodied carbon emissions of building material accounts for 15 to 50% of the entire building life cycle emissions, depending on the building types. Therefore, reducing the embodied carbon emission of building material really helps to reduce the carbon footprint of building and construction sector. Among the numerous of building materials, iron and steel-based products are the most commonly used one and with the largest carbon intensity. Research have proved that steel-based material has the largest carbon emission shares in modern construction, following the concrete and cement. The steel-based building material could account for as much as 37% of the total embodied carbon of an entire building. Therefore, being one of the industry sector that have the most energy and carbon saving potential, iron and steel industry has the obligation on carbon reduction. In recent decades, increasing number of research has been conducted, aiming for mitigating the embodied carbon of iron and steel products. In spite of the increasing research on this topic, very limited study has been conducted to systematically review the available results of them. Therefore, this study holistically reviewed the existing research with an aim to explore the current research trend and challenges. To achieve this aim, this review study firstly identifies the most commonly studied carbon reduction strategies. And then, the current status, features, and limitation of this research has been disclosed. Finally, challenges and barriers of implementation of these reduction strategies are disclosed. This is the production process map of steel building products, which includes the raw material preparation, such as mining, coke making, iron ore sinter or pelletizing, iron making, steel making, and final product fabrication. It should be noted that the iron making process emits the most part of the carbon emission of the entire manufacturing process. This study starts by a search of peer-reviewed journal articles in literature database, such as Science Direct. As this is a rapidly developing research topic, this research results only consider the articles published in the latest 10 years. As we know that the life cycle of iron and steel building product consists of several stages, but this study only focuses on the low carbon strategy applied within the cradle to site boundary, namely from the raw material preparation, iron making, steel making, to the semi and final product fabrication. After an initial search, over 450 peer-reviewed journal articles were identified falling within the subject. After a review of the content, 46 representative articles were selected for this reviewing study, as they provide very detailed analysis of the carbon reduction strategies or measures. As a result, 10 groups of most studied carbon reduction strategy were identified. The results show that about half of the reviewed study analyzed the performance of multiple carbon reduction strategy as an integrated system. In other words, half of the study has analyzed the synergy of several carbon reduction measures rather than the effect of a single measure. Then we can observe that more than 1/3 of the reviewed article analyzed the carbon reduction measures related to the iron-making process, which is in line with the fact that the iron-making process emits most part of the carbon emission of the manufacturing process. On the other hand, the management measures and the policy drivers have been seriously overlooked. Taking the local material as an example, adopting local material is an important carbon management measure. In China, for example, import more than half of the iron ore from overseas, mostly come from Australia and Brazil. If the local iron ore or the iron ore from Asia or near Asia countries could be used, the transportation carbon emission can be substantially reduced. Moreover, we observed numbers of challenges and technology barriers of implementation of the carbon reduction strategies. Here are 4 examples. Regarding the direct reduction of iron ore with hydrogen, the main challenge is the availability and the cost of hydrogen. Besides, majority of the hydrogen are produced from natural gas, which is a fossil fuel. This process gives rise to carbon emissions as well. Therefore, the hydrogen production today is not yet a very entirely clean process. The electrolysis of iron ore has not yet been applied in commercial scale because of its low productivity. Waste gas recovery from furnace also needs to improve its efficiency of gas separation, utilization, scheduling system. The carbon capture and storage faces the challenge of purification system of carbon dioxide, the risk in transportation and storage of carbon dioxide, and the high capital cost. This review study has reviewed 46 relevant peer-reviewed articles, and 10 groups of carbon reduction strategy has been identified. It is observed that the alternative iron-making process, alternative reducing agent, carbon capture and storage, waste gas recovery are the most frequently studied technology improvements to achieve low-carbon steel building products. This research finds that the carbon reduction strategy usually work cooperatively to achieve the maximum performance. One important finding of this study is that the relevant policy driver and management measures have been largely ignored in the existing literatures. Then, the challenge and barriers of implementation of the reduction strategy are discussed. The findings of this study are expected to contribute to the body of knowledge and also help the industrial practitioner to improve their environmental strategies. Because of the word limit of this paper, only 46 peer-reviewed articles have been reviewed. Therefore, more articles should be covered in future study. Besides, quantitative evaluation of carbon reduction potential should be further reviewed in detail in order to disclose the effectiveness of the carbon reduction measures. And that's all for today's presentation. I thank you all for listening. Any question and suggestion is welcome.
Thank you very much, Yuan Chen. That was a very interesting presentation about embodied carbon of iron and steel. So I will open the floor for questions. If anyone has question, can you please unmute yourself and ask the question? Why I wait for people that might want to ask questions? Let me start by asking a question about the article. It's a very interesting one, because when you consider the way things are going in the industry with the increasing use of sustainable system during the operational stage of building, the embodied carbon of the building is becoming increasingly important within the built environment. So with this study, let's consider we as practitioners in the industry where we don't have the ability to change the policy directly, or we don't have a choice or the kind of control on how the iron and steel are manufactured. What, from your study, what do you think we can do in the industry as practitioners to minimize the embodied impact of carbon? Embodied carbon of iron and steel, I mean.
Sahid, well, thank you very much for your question. Can you hear me well?
Yeah.
Okay, for your question, I think what the industry practitioner can do first to improve the technology they currently adopt. Take China as an example. We know that China produces half of the global crude steel. That's a lot of share. Unfortunately, 19% of the crude steel produced by China are produced from blast furnace, which means only 10% were produced from the electrical arc furnace, which utilize the recycled steel as raw material. So this one is a very environmental friendly process route of steel. So what I would suggest the Chinese practitioner to do is to replace as much as the blast furnace as they can and install the electrical arc furnace. Of course, this will largely depend on the availability of the recycled steel. And therefore, as the end user of a building, recycle as more as the rebar or structural steel is what can they do to support this change, this revolution.
Thank you. That's really interesting. So it's very important for practitioners to also be aware of all these significant steps that could be taken to mitigate the environmental impact of the material that they are recommending. Thanks so much for that, Yuan Chen. That was a very interesting one. Let me accommodate one more question. Any other question on this before we move to the next presentation? All right, so thank you so much. And if any other person has any question on the first presentation here, which is on the review of embodied carbon reduction strategies of iron and steel building products, if anyone has any other question, we can take that question towards the end if time permits. So can we move to the next presentation, please, Ali? The second presentation is by Shuaib Arugunda. The topic is on carbon reduction during building construction projects, trend mapping from construction journal. It's also a systematic review, and it's also looking to the strategies for reducing carbon during the building construction stage. It's a little bit different from that of Yuan Chen, because she looked at the embodied carbon of iron and steel as material, but this is looking at the carbon reduction during the actual construction process, which is another stage of building life cycle processes. So can we have the presentation now? Thank you.
Hello. The title of my paper is Carbon Reduction During Building Construction Projects, Trend Mapping from Construction Journals. A quick introduction. Recently, there's been an increasing attention on embodied carbon reduction of building construction projects. However, most of this attention have been concentrated on carbon emission as it relates to construction materials, with construction activity related carbon emission being largely ignored. Some of the reasons that have been presented or highlighted has been that the embodied carbon emission of construction materials are the highest, while those emitted during the construction stage is very minimal. With this in mind, this study set out to explore this claim by answering 3 research questions. And number 1 is to look at the annual publication of studies around this area that has happened in the last 2 decades. Secondly, to look at the geographical spread of authors and institutions that have contributed in this research area. And lastly, to look at the key themes and research area that have been covered, equally to look at the emerging ones. A brief explanation regarding the scope of this study. So the building life cycle stage embodied carbon emission was adapted from European Committee for Standardization, and the embodied carbon that we are going to be looking at in this study is the construction process stage. That's the stage A4 to A5 only. The methodology adopted for this study followed that used by Dako and Chan 2016, Charef et al. 2018, and Deng and Smith 2013, with some modification. Keyword search was done on Scopus database, and the 2 strings of keyword that was used are carbon reduction, carbon emission reduction, greenhouse gas emission. That's the first keyword. And the second keyword was building construction phase or stage. And on the right-hand side shows the flow chart summarizing the search strategy that was adopted. In all, 30 paper was screened and they became eligible for the study. Findings and discussion. So this slide is talking about the annual publication of studies, which relates to the first research question. From the study, we discovered that in the first decade, that is between year 2000 and 2010, only 1 paper was actually published related to construction process emission reduction. And this could be due to the fact that, as highlighted in paper by Abedira 2019, that it is until 2007 that research in the old carbon emission area began to significantly rise. Another thing to note is that between year 2014 and 2018, 18 papers were published as found by the study. And this shows a rise and increase. And this increase, as highlighted by Abedira again, is that the IPCC climate change report actually came out in year 2014. And this saw a spike. Okay, this actually motivated researchers in a way to start researching in the whole carbon emission area generally. So this was felt in the building construction process carbon emission reduction research as well. Equally, in 2017, there was a dip in research in the study area looked at in this present study, right? And from 2017 up until now, research has actually been dwindling in this area. And this could be due to the fact that most of the study in the building construction process carbon emission research have been done in the context of life cycle assessment, okay? And because all the research is done in the life cycle assessment area, using the life cycle assessment methodology, have shown that construction process carbon emission is low. In fact, some of the tool that is being used to carry out life cycle assessment on building construction generally, they actually exclude the process of capturing construction process carbon emission generally. So this might actually be responsible for the low research that have been seen in this area. Secondly, to look at the second research question, looking at the geographical spread of authors. So it was found that 15 countries actually contributed to the studies that we found for this paper. And out of those 15 countries, China, US, and Australia were found to have the number of researchers that have worked in this area, and they've published quite an amount of paper in this area. Again, another thing is that there is no intercontinental collaboration that was found, apart from, people, researchers carrying out research in the same region. And the region that was found to have collaborated is China and Hong Kong, as well as Iceland and Finland. More about this can actually be seen in our paper. Then the research covered and the emerging themes. As highlighted earlier and as shown in this network diagram, we found out that the greenhouse gas emission research generally in the building construction area actually took off in 2015, 2016, and from 2018 till now. Okay, the papers actually show that research areas that have been covered are those related to concrete, structural design, eco-design, concrete material recycling, etc. And these are terms that are related to carbon emission from construction material, which is actually supporting the claim first raised in this study. Another thing that we found is that construction phase, supply chain, and greenhouse gas emissions are a bit close together in this network, and it's suggesting that probably these areas have actually been researched together, and is quite not surprising because also researchers have said that 99% of emissions have been related to 99% of emissions from building construction have been related to those coming from the supply chain partners. I think this might probably signal that a lot of efforts needs to go into reduction of carbon from the supply chain partners going forward. And in conclusion, it is important to note that this study actually supports the claim investigated, that is, those that are suggesting that carbon reduction during building construction process have been largely ignored. And from the papers that we were able to go through, those that made it to this study, it was shown that even if a particular researcher actually set out, to understand the building construction process and carbon emission reduction, you discover that by the time they would be suggesting tactics to reduce carbon, they will be suggesting tactics that only favors construction materials. Another thing to note is that in starting out this study, we actually intended to focus on construction management journals alone, but conference proceedings were included at the end of the day due to the limited number of publications that we found in just journals. And this effort actually paid off because we saw papers like Satari and Thorpe 2012, Wu et al. 2019, that actually contributed immensely to this research. Then lastly, the findings of the study is probably going to be particularly beneficial to researchers and stakeholders with interest in construction carbon reduction, as this may actually shape the outlook towards the field and also towards the efforts of research in reducing carbon during construction process. Equally, efforts of publishing after carrying out research, publishing those research in these areas. We thank your hub, Leeds Beckett and EverX Consulting for supporting the researcher. And these are the references. Thank you. Hello, the title of my paper.
Yeah, thank you very much for that, Suhaib. That's another interesting presentation about the impact of construction project generally, and it was started by also making reference to the different life cycle stages, just like the previous paper as well. So it shows that all these stages are very, very important when we are talking about the impacts of a construction project on the environment, and that impact is not limited to this, also impact when the building has been completed and the building has been operated. So thank you very much once again for that. So questions, please, if you have a question, can you kindly raise your hand and I will be able to take one or two questions on this before we move to the next presentation. So while you're waiting for that, Shuaib told us about the past trend, how the study have been done in the past. From what you have done here, So do you have an idea of where the research might go moving forward?
Thank you very much, Dr. Ajay. Based on the research that was done and the analysis, especially from the network of keywords, I would imagine that research going forward is probably supposed to focus on the carbon reduction efforts within the supply chain when we are talking about the construction process itself, because that's what is largely missing during the research. That was what was found out that was largely missing during the research. That's number one. And number two is that I would imagine that also due to the fact that contractors are sort of responsible for bringing the building to life, there should be some sort of collaboration between researchers and the contractors in understanding efforts and also in implementing the necessary carbon reduction strategy while carrying out construction project. And once this is done, this should probably be captured in maybe presentations like this, so that the industry as well as academic researchers as well as other practitioners and policymakers will be aware of what is the current state of happenings and also where the challenges might be and also what can be done to assist the efforts going forward.
Thank you very much for that. Professor Chris Goss.
Excellent presentation. Thank you for that. Really good to see you focusing on the construction phase. I'm just interested in obviously when you do focus on the construction phase, the energy and transportation accounting for carbon emissions and embodied carbon during that phase. Once you've captured what's actually happening, might be relatively straightforward, but I just wondered for some of those almost the sacrificial products that are used during construction, have you started to consider those, and then the differences that might be found when you're using different embodied carbon metrics to quantify products that we use to go through the construction phase, but we do dispose of.
Thank you very much. So regarding the first aspect of your question, so the construction process actually combines the transportation of the material to site also. So what we have done is to look at using the RIBA life cycle stage as a yardstick. So the A4 and A5 is what we consider as the construction process stage. So we have also captured the transportation aspect within this research. So just to some sort of information regarding that. So secondly, so based on what you have said, I would imagine that that's why the life cycle assessment methodology and tool, that's why researchers have been using that. Also, the industry practitioners have also been using that to sort of look at the carbon emission relating to the building construction generally. However, what that has done, and it might actually not be a plus, it might be a negative. What that has done is that is making the construction process stage to be sort of under looked or what was the right word to use? Like, people don't focus on the construction stage that much because it is believed that the carbon emission from that stage is very minimal, so it gets ignored. Having said that, if you look at the material, just like you have rightly highlighted, if you look at the material, the embodied carbon of the material when it comes into the construction process stage, the end of life is another thing to look at when it comes to the material. And from the what do you call it? From the papers that were examined, I think just about 2 of those papers actually mentioned the end of life stage of the material, considering that while measuring the carbon emission of material. So there is no common metric or common yardstick by researchers when they are looking at, the carbon emission from the building life cycle generally. And this is one of the things that I think we need to focus on going forward in terms of trying to, having a yardstick that would be widely accepted and probably implemented both within the industry and amongst researchers when thinking about construction carbon emission generally.
Okay, thank you for that. I don't know if there is any follow-up question from Chris on that before we quickly move to the next one.
No, thank you for that. Thank you, Salim.
All right, yeah, thank you very much. Ali, can we have the next one, please? So this one is the next presentation is from and the presentation is titled Integrating User Satisfaction to Support Decision in Sustainable Development. So we'll listen to the presentation and kindly note down your question. We'll be able to take one or two questions after the presentation. Thank you.
Hello everyone, my name is Dima Al-Kawadri. I'm going to present my paper today, users' satisfaction to support decisions in sustainable development. With the growing concerns on the environment and the rapid consumption of scarce resources, the green building movement and sustainability initiatives started to rapidly grow and stress the importance of sustainable development and the related benefits under the sustainability three dimensions: the social, economic, and environmental. However, many of the certified building performances were not always aligned with the desired sustainability targets. Sustainability assessment have vastly spread after that, and they are considered user-friendly and cover most of the substantial aspect of the sustainable developments. However, environmental consultants are inclined to follow the client's aspiration aimlessly without balancing user needs and satisfaction to achieve the highest 3D benefit. This is what we found in the study. The sustainability assessment systems and scoring structure is also a comparison contributor to that argument. Studies showed that the current sustainability initiatives and rating system could not successfully capture the acclaimed 3D dimensional benefit of sustainability. So the rating system scoring structure gives the more weight to environmental than social and economic aspect, as we see in here. Following these systems in return blindly would lead to a level of certification, but not the desired impact. The current trend follows the rating system aimlessly based on the as a client aspiration, as we said, as a target. So and as each project is unique and each occupant or user has a different understanding of what the quality of life in a home or a workshop looks alike. Improving the social aspect has proven to impact on the strengthen the business case of sustainable development through increased productivity and reduced absenteeisms, as the literature showed. So UK Green Building Council has connected users' comfort and happiness to a positive impact on client business as a result of more productivity in these two cases. And the literature showed that organizations also like M&S have tried to include user perception to empower their business case. So the study aimed to support the environmental consultants with their decisions on different sustainability solutions and looked at how to optimize sustainability value in sustainable developments in balance with the end users' comfort and satisfaction, as they were proven to increase productivity and contribute towards more social and economic benefits. So the aim of the study is to optimize the sustainability value by integrating the user preferences and levels of satisfaction as a leading role player in balance with the UN SDGs and the extent of the scoring points. So this study utilizes a LEED frameworks, which is the most widely used green framework in the world, and is aimed at creating, and the study aimed creating an appropriate hierarchy of LEED credit options by looking at the corresponding average weights given by the users to aspects from LEED and WELL framework, and helping the consultants in that sense. The selection of the methodology was a survey questionnaire. The selection was due to different factors. The need to find controversial and diverse participant is one factor that is hard to achieve via other methods. Also, the sampling is challenging. It is difficult to find information about anonymous people. So therefore, the survey was circulated online to involve employees and residents in the UAE using LinkedIn database via emails. The survey is meant to end users. However, the authors targeted LinkedIn users to involve employees in the UAE. So the survey was designed using Google Forms and the snowball sampling approach to reach a broader sample. The first 3 surveys were used to test the survey design as well. So 65 participants from the UAE region have filled the questionnaire and assessed various aspects inspired by LEED and WELL building standards framework. And the survey was conducted to scale the user's perspective and satisfaction on environmental, social, and physical factors, being provisions and nourishments on scale from 1 to 5, where 5 is the highly important. So a weight was assigned to each credit option based on the end user preference to different aspects from the survey questionnaire results. And the preferences given by the user were transferred to average user preferences weight in 3 steps of calculations to reach the final value. The value represents the average weight of an aspect given by users and reflects the user's perception, of course, of these credits related aspects. So LEED framework was chosen as foundation of the study, hence the user preferences weight was associated to LEED credit options. The credits were then linked to the UN SDGs to support practitioners in the UAE on accreditation with decisions towards better sustainability benefits based on the desired impact. So these are 2 examples of what we did. So the study surveyed end users to generate broader understanding of credit's contribution to user comfort and satisfaction. The study helped to understand users' perception of these factors and aspects better through their assigned average weight. So users gave higher importance to some environmental factors, reflecting the improvement in users' awareness and understanding of the impact of these factors on users' health in an indoor environment. Factors inspired also by WELL standards related to nourishment, well-being initiatives, and layout design aesthetics area were also part of the study to improve the social implication of sustainable developments. Results showed that most of these aspects were assigned almost equal importance, yet equal average weight to user satisfaction and comfort. Access to healthy food with pricing incentives and office interior layout, aesthetics, workstation configuration and density were also crucial to users. The last step was connecting also credit options to UN Sustainable Development Goals to help to prioritize the credit's contribution to a particular goal. These steps help support practitioners in the UAE on LEED accreditation decisions by emphasizing the social aspect and integrating it as LEED role through the credit selection process. Thank you so much, everyone. And these are our emails in case you would like to know more about our study. Thank you.
Thank you very much, Dima. That was interesting. Trying to bring in users who are the important stakeholder that are often neglected when we are talking about building design and construction. So that's a really interesting one. So questions, if you have a question, please kindly raise your hand while I start with a question. So my question, Dima, is about what you find out, which is definitely interesting. I think Dima is still here. Yeah, great.
Yes.
So
Yeah.
the question is about what you find out. Is there any relationship? Is there any link between what you find out as a user preference and what sustainable design assessment appraisal system like Leeds, BREEAM, and the like, what they focus on and what user prefer? Is there any relationship, or you've not been able to compare that?
Hello, hi. Can you hear me clearly?
Yeah.
Yeah, so the rationale behind the study was originally because of the sustainability assessment frameworks, where they, as was mentioned, basically focused on the environmental pillar. We all know the sustainability works on 3 pillars: economic, social, and environmental. So the LEED, for example, focus 12% only, gives weight to social pillar as 12% only compared to environmental and economic one. So the social implication of the decisions of these experts while selecting these credits is always kind of neglected. The results was done the results were in a way a little bit connected, while it shows the awareness of the end users, because they gave also crucial weight to environmental aspects or factors that were asked about. However, a lot of because the rest were more, kind of a little bit neglected in LEED when they gave more importance towards different, aspects related to well-being and the value, their perception of the space in general, the value of the space in general. So that's why the study focused on aspects from LEED and WELL framework. It was targeted towards also the users in UAE. So LEED is mostly focuses on water and energy, and that's why it's a bit disconnected from the social pillar in general. So that was the reason behind the study.
Thank you very much. That's interesting. Let's move quickly to the next presentation, please. Our time is fast spent. The next one is from JITS, and the presentation is titled "Towards Automation of Sustainable Green Building Materials in India." So listen to that, then that will be followed by a question. So kindly note down your question. Once the presentation finishes, then we'll be able to take questions.
Greetings of the day, everyone. I am G. Trivedi, and I would be going to present my research towards automation of sustainable green building materials in India, which I have done under guidance of Professor Jyoti Trivedi. The AEC industry has had a reputation for being a major contributor to negative effects on environment. Due to the deteriorating environment, the focus is shifted to improve and protect natural resources. So the concept of green building is introduced to tackle environmental challenges. A green building is a building which in its design, construction and operation stages reduces or eliminates negative impacts on the climate or natural environment. Nowadays, the extensive use of computers, architecture and engineering software demonstrate their tremendous role in the AEC industry. So, the Building Information Modeling or BIM can support the collaboration between various stakeholders throughout the project lifecycle by providing facilities to insert, extract, update or modify information in the BIM model. Several researches have been conducted in the areas of construction optimization and decision making, leading to development of a number of optimization models using a variety of approaches. Here, initial rating system for green building is proposed to fit sustainable environment. This rating system is called EcoDEA Green Building Rating Systems or EDGARS. Currently, for green building ratings, the traditional computer-aided design or CAD drawings are submitted and used for evaluation. If there are some variations in the drawings, then the evaluator has to manually change the values in template, which sometimes might cause errors. This is the main purpose for automation of rating systems. Assessment of how sustainable or environmental friendly any product is a very huge task. Each building material has another 100 variants. In this case, decision making becomes a big headache. Need for assessment tools that can rank or compare two or more than two materials arise. Issues like carbon dioxide emissions, resource efficiency, energy use, waste generation, water, toxicity, etc. are all single parts of the whole sustainability picture. Many assessment methods try to find the answers to these questions. They aim to quantify the impact of one or several of the above sustainability issues and to identify the key drivers. Principles which a sustainability assessment method should follow are holistic, scientific or objective, cost effective, easy to communicate or understand, decision oriented, and labeling if possible. The method providing the most holistic approach is the eco-efficiency analysis. It combines two pillars of sustainability, economy and ecology, and therefore gives the most complete information to the decision maker. It is followed by quantitative cradle to gate approaches since they cover multiple environmental criteria. The objective of the study is to develop framework for green building sustainable rating system GRS by integrating BIM technology that is dedicated for selecting sustainable green material selection. A three-stage methodology was adopted for the research. First, development of BIM model to establish relation between BIM and IGBC. Second, EcoDEA mathematical model approach for optimizations and selection of sustainable material criteria. Third, to create an integrated framework that is dedicated for selecting optimum sustainable building materials that developed expanding the features of BIM technology. The flow of research is as follows. Current AEC drawings are converted to parametric model using Revit. Then programming in Dynamo is done to rate the building materials as per IGBC. Then optimization and integration of model is done in support with various stakeholders for an integrated project delivery, which is a long-term goal of BIM implementation. So, discussing the methodology, the first stage approach, Autodesk Revit 2020 has been used as a BIM modeling software and Dynamo for analysis. Scripting is done for a BIM model to demonstrate the practical approach. Scripting is done in Dynamo to extract the information from BIM model to MS Excel for evaluating the green building score as per IGBC. The Dynamo script prepared is for the evaluation of 5 parameters of the green building materials as per IGBC. These are distance from source of materials in kilometers, whether the material uses FSC certified wood, whether material has a Green Pro label, whether recycled contents are used in the materials, or whether salvage materials are used in the building material. Second stage approach is EcoDEA mathematical model approach. So eco-efficiency emerged as a management philosophy by the World Business Council for Sustainable Development WBCSD in 1993 following the 1992 Rio Summit. The definition at that time was given as the delivery of the competitively priced goods and services that satisfy human needs and enhance the quality of life while progressively reducing the ecological effects and resources intensity throughout the product life cycles to a level appropriate with the estimated capacity of the earth. As per definition, eco-efficiency is usually defined as the ratio of economic value added to the index of environmental pressures. So it is majorly dependent on two variables, economic and environmental. There are various methods for deriving eco-efficiency ratio. In this study, LCC and LCA will be utilized for eco-efficiency ratio. Hence, eco-efficiency is defined as life cycle cost upon life cycle analysis. Eco-efficiency improvement can be accomplished by reducing the environmental effect added while increasing the economic value added for products or services during their life cycle. The third stage approach is an integrated framework. Here, the materials and their properties are added as an input to a BIM model, wherein the dynamo programming is done for rating of building materials as per IGBC new building rating system criteria, as well as these material and properties are added to an EcoDEA optimization model to calculate life cycle cost and for life cycle analysis. It is important to note here that LCC and LCA analysis can also be an input to a BIM model for calculating LCC and LCA of whole building. So the results for stage 1 Dynamo script are seen. Here credits achieved is calculated based on the inputs in the BIM model. The results from BEES software for the DEA can be seen. Here only exterior wall finishes were evaluated. Because there is an imbalance in the data magnitude, the data were mean normalized, a procedure that is followed to prepare the data for DEA. Mean normalization was conducted by calculating the mean for each input and output and dividing each input or output by its respective mean. A solution set is derived using linear programming models in MS Excel solver and eco-efficiency ratios were derived. Here it can be seen that the eco-efficiency ratio varied from 2.34 to 1.17, where cement plaster was found to be most eco-efficient material, while structural glazing was found to be least eco-efficient. This result also showed that DEA is an effective tool to evaluate construction material alternatives and offer a critical insight to a decision maker that can lead to buildings that use much more eco-efficient materials. So in conclusion, we have seen that process and efforts were developed facilitating stakeholder inputs of a green building, then developed a green building material scoring model, then developed an additional evaluation of properties of different green building material parameters. Here, DEA compares eco-efficiency by analyzing other sections in the dataset. EcoDEA model utilized the framework of LCC and LCA and calculated the ratios and created EcoDEA Green Rating System or EDGRS. In future, complex programming may be required to analyze the materials separately and not as a whole element in a BIM model. Also, in future, different DEA formulations could be developed and assessed for different decision-making settings. Thank you. Greetings of the day, everyone.
Thanks very much. That was another interesting presentation that automated the calculation of the impacts of different building material. So let me ask, is the presenter here? Is Jit here? I doubt that. And then let's move to the next presentation because we don't have anybody to answer any question on this here. So the next presentation is by Mahmoud, and the title of this one is on developing an early prediction model of bankruptcy in the UAE construction industry. We know that bankruptcy is a big one when we talk about the construction industry, and this one to look into how do we predict bankruptcy within the industry. So there will be opportunity to ask a question after it. Before you play it, please, Ali. So can I ask if the presenter is here? Mahmoud. Yeah.
Hello, everyone. Yes, I'm here. Yeah. Yes.
Great. Yeah, thank you very much.
Greetings to everyone. I would like to welcome you all in my presentation, developing an early prediction model of bankruptcy in the UAE construction industry. Our presentation agenda will start with introduction, following by the importance of construction to the economy and the construction culture in the UAE. Then we will cover the research gap, aim and objectives, and explain the methodology used in the research, illustrate the developed model, and present the finding and results, and finally, conclusion. To start, introduction about bankruptcy, where there are several meanings of bankruptcy. However, the simplest way to explain bankruptcy where the organization's liabilities exceeds their value of assets. To overcome the risk of insolvency, companies tend to finding new funding resource,
restructuring the company, and appointing liquidator. Moreover, the benefits of bankruptcy protection model is to predict any future insolvency, identify the cause of the problem, and take corrective actions. The development of bankruptcy prediction model started with the initial approach of comparing between indicator, then debt scoring by ultimate, and finally multivariate linear discriminant. Now we will talk about the importance of construction industry to the economy, where there are two factors affecting any market stability. The first factor is the quality and performance of the market, such as the level of debit risk, the level of building material consumption. The second factor is the behavior towards current and future challenges, such as the financial crisis, global warming, and the pandemic. Moreover, the importance of construction industry to the economy have several levels. On the social level, by creating more job opportunities, the governmental level by expanding on government projects, economical level by contribution to the GDP with the highest percentage in comparison to the other industry. However, construction industry has a lot of uncertainties and high risk, such as constant failure of project delivery on cost and time, project dispute and change of design, contractors' short and long liabilities. Now we will talk about the culture in the UAE construction industry, where the UAE government vision is to build smart and flexible cities, with winning of Expo 2020 allowed of delivery of fast-track projects. Majority of project delays in the UAE is due to payment delays, cost overrun, arbitrations, and liquidation. However, the reasons of bankruptcy is due to poor operations, poor contract practice, insufficient profit. Now we will talk about the importance part of the research, where the recommendation that the UAE government rule to control the payment delays to the supply chain and introduce and implement new form of the contract and new payment mechanism. However, the limitation were in the lack of transparent and published data, and the most important on the selection of the criteria and variables when creating the model will depend on each organization strategy and vision. The aim and objectives of the research to understand the reasons of bankruptcy. In absence of bankruptcy prediction model, what are the organization's strategies towards the risk of insolvency? To rate the challenges facing creating a bankruptcy prediction model, and finally, to evaluate the developed model considering implementation. The methods used in the research started by collecting comprehensive data from the literature review on the important role of construction industry to the economy, to identify the reasons of bankruptcy in the UAE construction industry, and to understand what are the current tools and methods used to overcome the risk of insolvency. Where the results of the literature review were used to create a questionnaire which was sent to the different players in the UAE construction industry, and the results were analyzed by using quantitative analysis, which also helped in preparing the questions in the interview with the professional expertise to help on creating and developing the bankruptcy prediction model in the UAE construction industry. The concept of the developed model will depend on each organization strategy and vision. However, it is very important to select the most important criteria from the developed model, either to be accurate, flexible, and updated. Moving on to the second step by selecting the most important variables between the financial, construction, and macroeconomics. The design of the model will depend on three layers: input layers, processing layer, and output layer, to decide on the company either to be healthy or failure. The finding from the research is the most common reasons of bankruptcy in the UAE construction industry is due to payment delays from the client or no payment at all, which is affecting the supply chain. However, the client neglected quality and risk of variations. The current strategies from the organization is to follow back-to-back payment, cash collection, and selecting of clients. The most important criteria in the UAE construction industry when developing the model is to be flexible and updated. Now we reach the finding and the result of the research, where each member in the organization should understand their roles when it comes to the developed model. Shareholders should import the model, general manager to implement the model, accountant to monitor the performance, quantity surveyors to practice, and commercial managers to take corrective actions. Moreover, the evaluation of the developed bankruptcy prediction model was good, where the evaluation was the developed model was accurate, flexible, suitable, and effective. To conclude the presentation, the outcome from the literature review, survey, and semi-structured interview that the most common reasons of bankruptcy in the UAE construction industry can be divided into three sections: market condition, management, financial position. The main concept of the developed model is to classify the financial position of the organization. It is very important to understand that while developing the model, it's very critical to select the most important criteria and variables to each organization's vision and strategy. The recommendation that the government should implement new payment mechanism to the market and adopt and implement new form of contract. That will be the end. Thank you so much.
Okay, thank you very much, Mahmoud. That's a very good one. The study looking to develop an early prediction model of bankruptcy in the UAE construction industry. And as you rightly said, the industry is very important to the global economy, and the failure of construction company could lead to failure of other businesses that are associated with that. So I will open the floor for questions. So anyone that has questions, kindly raise your hand. So while waiting for question, so let me open the floor with a question to Mahmoud. From your studies and your general literature review, what will you say are the 30s that will tell you that a company is heading towards failure, towards bankruptcy? What do you think they will be doing that will clearly tell you as an expert in this area that this company is likely to fail within the UAE construction industry?
Hello, Ajayi and everyone. Excuse my voice, it's just I have a bit fever. The study was done to help the organization in the earlier stage and initial stage to understand the behavior of the market and the challenges, and to protect any future, not when it's already occurred, as much as to be ahead of such a situation, because recently, due to different reasons as per the study I have done, there is new market entrant, people are having insufficient profit, which affecting their performance during the project. So it was an interesting topic to help them to have a prediction model depend on each organization vision, because a subcontractor will have a vision different from a client, from a main contractor, from a specialist. So everyone will have his own vision and requirements from the model. It will not be a standard one for everyone. As much as everyone will have their own data, and they have recorded data from previous years to compare between the current performance and indicators in comparison to the previous years. So the model will help them in the initial stages to predict and understand where was the default or where went wrong in the earlier stage. But it was not involved in if the organization already failed into bankruptcy, what will be done to help them. That will be like a different topic, I believe. That's it. I hope I answer your question.
Yeah, that's fine. My question was actually what would be the kind of behavior that you will see that will tell you as an expert that if this company continues in this direction, they are likely to run into trouble. So that was the question. But you've been able to explain even more than what you've put in the presentation. Thank you very much for that clarification. So let's move to the final presentation, which is by Ali, and that is an investigation of the influence of public clients on contractor behavior towards a modern method of construction. So we know that modern method of construction is we are advocating for it within the industry. We want the industry to modernize. So this study is going to tell us about what the public client can do to actually drive the behavior towards this approach. Thank you.
Hello, everyone. So my name is Ali Saad, and I'm a PhD student at Leeds Beckett University. And in today's presentation, I'll be presenting part of my ongoing PhD, where I look at promoting the modern method of construction as an innovation among the construction industry, particularly among or across the public sector, among public clients. So this presentation is titled An Investigation on the Influence of Public Clients on Contractors' Behavior Towards the Modern Method of Construction. So, as we all know, our industry is not the perfect industry. In fact, we are lagging all other industries in terms of innovation, in terms of change, in terms of environmental impacts, in terms of health and safety, and in terms of cost and time overruns. So this industry is not pressured to transform and adopt new practices, innovative practices that would help it to address existing issues and existing challenges. So we have an emerging innovation, an innovation that we are hearing about a lot the past few years, which is the modern method of construction, or MMC. It is basically ways to transform current practices to a more controlled environment with less labor. That's basically the definition of the modern method of construction. It is perceived perhaps by some as a way to transform major activities off-site, then transport those activities, then assemble them on site. So three main phases of design: construction off-site, transportation, and then assembly and delivery on-site. A recent UK governmental report categorizes MMC as 7 different categories. The first category is pre-manufacturing 3D primary structural systems, like volumetric units. The second category is pre-manufactured 2D primary structural systems, like panels and wall structures. Category number 3 is pre-manufactured components, non-systemized primary structures like beams, columns, slats that are mass-engineered off-site. Category number 4 is additive manufacturing structural and non-structural systems like 3D printing, for example. Number 5, or category number 5, is the pre-manufacturing non-structural assemblies and sub-assemblies like bathroom and kitchen assemblies. Number 6 is traditional building product-led site labor reduction and productivity enhancements like features to actually improve productivity and reduce labor, as mentioned before. And the last but not least category is the site process-led site labor reduction, productivity enhancements, and assurance improvements, which is basically techniques that can lead to less labor, more assurance, and more productivity improvements. So this is the modern method of construction in a nutshell. So similar to the traditional sector, we have key actors in the modern method of construction sector, contractors, and so in this study, are particularly focusing on public clients. Public clients are clients that receive funding from the public. So they differ in their behavior, in their activities, in their strategies, into how they procure construction projects different or compared to the private clients due to their pressure or the different aspects surrounding their procurement activities. Contractors, on the other hand, are the same. Contractors are reluctant to change. Contractors have this tendency to as we all know, to just reject anything new. They are not widely open, or most of the contractors are not widely open to change. They focus on their 30, 40, or even more years of experience in the construction industry, which makes them this emerging or characteristic of being reluctant to change and to innovation in particular. So the framework that I'm trying to build and develop, or the workflow of my study, is to look at whether or not MMC is an interesting alternative for both supply and demand. So, can the benefits of MMC drive contractors to embrace such methods into their practices and supply them and deliver them and offer them as a service? On the other hand, how can we promote the decision of public clients to consider and accept MMC as a construction alternative? So when we are looking at the supply side, we are looking at business models and whether adjustments or enhancements within current existing business models can enhance the diffusion and the better adoption of the modern method of construction. On the right hand, we can investigate, or we need to investigate, what are the potential limitations within current public procurement activities that might be underpinning the adoption of an innovation or the adoption of the modern method of construction. So once those understandings are acquired of business models and current procurement activities, we can then look at the theoretical adoption of the modern method of construction and the influences on its wider adoption and diffusion. So, in a nutshell, can adjustments in business models from the supply side promote or increase the adoption of MMC? So to achieve that, we have to understand the current existing business models. So our activities within current public procurement practices are potentially unintentionally limiting innovation due to their nature, underpinning or rejecting innovation due perhaps to the lack of objectivity throughout their public procurement practices. And then we have to understand this interaction between both public procurement strategies and business models and the supply side, and to understand how suppliers are actually ensuring these competitive advantages, how suppliers are ensuring throughout their, or contractors throughout their business models, how they are ensuring to enhance their commercial standing to sell such innovations to public clients. Also to understand how public clients perhaps are limiting innovation through their, or unintentionally limiting innovation through their current practices, to understand that there is public procurement frameworks which are innovative ways to procure construction projects. They are being used for many years now, and they are proving to be effective in ensuring collaboration. So this study will understand how can public procurement frameworks drive the behavior towards accepting innovation, towards embracing the modern method of construction as an effective construction alternative. I think I am behind time here, so thank you for watching my presentation. I hope you liked it.
Okay, thank you very much, Ali. So that's another great one. The impact of the public client, it cannot be overestimated when it comes to driving how the project is going to be run. And that again stress some of the things that we've heard on this particular track about the impact of client, how clients are very important. And once the client is the public, is the government sector, then the impact is going to be very, very significant. So I will open the floor for questions, although we're already running late, but we'll be able to take one or two questions on this. Questions?
I'll just give a quick one, Saeed, if that's okay. Ali, just to put you on the spot, is what are the challenges with the public with the frameworks currently in operation? You know, how do you envisage this going forwards in terms of better, improved procurement routes and access?
Hi, Chris. Thank you very much for the question. So basically, current or existing public procurement frameworks lack, or may I say lack, the ability to embrace innovation and to accelerate this innovation across the industry. And by innovation, in my case, it is the model method of construction. And we are seeing that the market now is changing. We are seeing that the government noticed that there are some limitations with existing traditional procurement frameworks that are focusing on traditional construction activities. And they are trying now to offer those new frameworks under new names. They started with the dynamic purchasing system, then they evolved towards a dynamic purchasing system plus, and then now we are hearing a new term called the dynamic markets system, which was recently mentioned or published last week. So the industry or the public sector is aware of this traditional, may I say, not suitable frameworks to embrace and accept innovations and innovative practices, especially in a construction industry, especially in the uncontrolled environment that the construction industry offers.
Thank you very much for that. Is there any other question on this? Yeah, so I guess there are no more questions. So our time is fast spent. We've gone through 6 presentations, which are all of which are very, very interesting. So may I take this opportunity to thank all the presenters, Yuan Chen, Shuaib, Dima, Jit, Mahmoud, and Ali. So thanks so much for the presentation, and I'm sure we are going to be able to have access to your paper to be able to read more about what you've done on this. And for those that are doing this as part of doctoral studies, I wish you all the best. And for the attendees as well, thank you very much for attending this session. And this will be the end of the track 2. So thank you so much.